Hi, my name is Rachel Wan, and I chose Math Teaks. And my strand is number and operations, and my substrand is counting. So for my kindergarten teak, I found is count forward and backward to at least 20 with and without objects. So my activity that I found for kindergarten was to first have the students count with counting blocks, then have the students draw circles while they count to 20, and then have them count without any drawing or objects. This is appropriate for kindergarteners because it scaffolds counting, and the blocks and drawing help them visualize before we take away the objects. My second grade teak is to use concrete models to count fractional parts beyond one whole using words and recognize how many parts it takes to equal one whole. So I'm going to give my second grader manipulatives such as a circle that can be divided into parts to represent fractions. And I'm going to have the students count the total number of pieces in the circle, then take out the sections and have them count how many sections out of the total number of pieces. I feel like this is appropriate for second graders because it helps them visualize what fractions represent and helps them with counting fractions, similar to how we showed counting whole numbers to kindergartners. We're going to show how to count fractions to second graders. For my fourth grade teak, I found is to determine the corresponding decimal to the tenths or hundredths place of a specified point on a number line. So I'm going to use a bar model and split it into 10 pieces with an easy decimal such as 0.3, which is equivalent to 3/10. Then I'm going to put the tenths decimals from 0 to 1 on the number line, and then I'm going to erase them and have students fill in the blank on the number line. After they've mastered the tenth decimals, I will introduce hundredths on the number line. This is appropriate for fourth graders because it shows that a decimal is like a fraction in that it is a part of a whole, and the number line also shows that decimals are numbers just like whole numbers and they have a value to them. For my sixth grade teak, it is to identify a number, its opposite, and its absolute value. For the sixth grade activity, I'm going to use a number line just like I did for fourth grade. And to teach an opposite number, we have to introduce negatives. So I would introduce it through number line hopping. So I would have the kids draw a rabbit or a frog to hop from 0 to 6 and then hop backwards from 0 to get the opposite number, which is -6. Then I would ask my students to see how many hops from 0 to a certain number, which is the absolute value of that number. So I would have students draw number lines in hops. This is appropriate for sixth graders because I feel like it teaches them the definition of absolute value. It also teaches them the negative numbers that will introduce them to more complex numbers such as irrational numbers that they will learn in eighth grade. So the eighth grade teak I found is to approximate the value of an irrational number, including pi and square roots of numbers less than 225, and locate that rational number approximation on a number line. So for my eighth grade activity, I need to introduce square roots on a number line, so I need to teach what a square root is. I will start by having my students write down 2 times 2, 4 times 4, 7 times 7, 8 times 8, etc. And then I will teach the definition of a square root. Then I will have students convert square roots into numbers to put on the number line. This is appropriate for eighth grade because it is using what they already know, number lines, to introduce a new concept of square roots. What I learned about grade level appropriateness is that it is grade level appropriate if it builds on what they learned in previous grades and it scaffolds to new concepts. What I learned about the structure of teaks is that the teaks build on top of one another. From kindergarten, they were learning how to count, and in 8th grade, they were learning how to place irrational numbers on the number line. The strand of numbers and operations were kept consistent.